take a look at obstacle avoidance. So we're going to build a very simple obstacle avoidance program here. And we're going to do that using the collision detection and the distance sensors that are built into the Robotino. So the Robotino has distance sensors all the way around it, and we're just going to use one of them here to build a really simple obstacle avoidance program. Now, why might you want that? Well, if we zoom out on our simulation, you will see a big wall of boxes. And if I run a very simple program here, just step one, I'm going to connect to my robot and just run this first step, we will see that the Robotino will begin to drive forwards. If I speed it up a bit, so I tell it to run at 100, then it will continue to drive all the way over here until eventually it's going to smash straight into this wall of boxes. Not such a good idea. Okay, so if we reset the scene and we put our robot back, 100 I suppose will still do. What we can do is we can drag in one of the distance sensors here, and we're going to want it to change state when the distance sensor gets too close. So what I'm going to do is I'm going to create a new variable here. So we'll call it distance. We'll bring in our distance writer, and we will just map that across here. And I'm going to now run this again, but this time I'm going to monitor this value. So I see here 0.3. And then what I might do is I might just slow it down a little bit so that we can take a look here at the value as it changes. So we're going to run this Robotino kind of slow. Here we go. So Robotino is coming forwards, coming forwards, coming forwards. And as we begin to get towards these boxes, hopefully what will happen is that this value here will increase. So let's take a little look, still at 0.3. There we go. It's coming up. Perfect. So probably we want to stop the Robotino when it gets to about 1, I would have thought, because that's the point before we crash. So let's stop this and reset our scene. And now what we can do is we can come to our main program and we can say that we want to jump from step 1 no longer when timer is more than 5,000, but if distance is greater than 1. So if distance is greater than 1, what do we want to do? Well, we're going to jump into step 2. In my step 2, I already have the going back program. So we can do that for an amount of time. Probably 5 seconds is a little bit too much here. Let's just drive backwards for maybe 2 seconds. And then in step 3, what have I done here? So all I've done in step 3 is I've made it turn around. So if I show the descriptions here, we looked earlier, this Robotino OmniDrive controller, we have X and Y, but we also have here Omega. This is causing it to rotate. If I just run this one step, step 3, if I run that now, you will see that and connect to the Robotino. There we go. We see that the Robotino is now rotating. So let me just reset that again. You can kind of keep doing this, by the way. You can always just reset anytime you want to. It's quite easy to work with. And so we want to rotate probably for a few seconds. So let's do this. Timer is greater than 2000. Again, maybe 2 seconds of rotation. And once that happens, it will jump back into step 1. And of course, step 1 is just going to drive forwards again. We'll increase the speed probably to something like 50. And it will just keep going. So timer is working in step 2 because it's listed here. And it's also working in step 3 because it's also listed here. That's why I'm able to use the timer twice. So I haven't tested this, no idea if it's going to work. Let's find out. Let's make this simulation a little bit bigger, just so we can see our crash avoidance in all its glory. We'll connect to the robot and we'll start it up. Okay. It'd be really nice if this worked. Let's shimmy the camera around a bit so that we can see what's happening here. So it's getting close, and there we go. Starts driving backwards, turns a bit, and carries on. Is it going to go? Slightly too close. So because I'm only reading the first sensor, it can only detect things that are slightly in front of it. This is obviously something that we should try to fix. But I think we did avoid maybe too much braking on the wall there. Let's see what happens as we come around over here. There we go. Slight avoidance, slight rotation. We might hit into this red one. Oh, just grazed past it. Okay, So obviously there is a huge amount of improvement that we could make to this program. We could check multiple sensors. That would be definitely a good starting point. Maybe if we check maybe the first 3 or 4 sensors around the Robotino, and if any of them are too high, then we could use that to trigger our next step process. Why don't we take a look at that? Let's have a little go. So let's go into our step 1 here. What we're going to do is we're going to drag in possibly these 3 sensors. Now, I'm not sure, but I think, yeah, I'm pretty sure we're going to need, for example, sensor 1 and then 2 and then 9. So I think that would be the ones either side of it, because you've got the 1 at the front and then they'll go round kind of in a clockwise direction. So I think you'd need these ones to get like the 3 that are on the front. So it's a little counterintuitive, but I suspect that's what you would need. Okay, so what we can do is we can maybe perhaps change the logic here so that rather than just taking the first sensor and piping it into distance, we could do here something like a, let's see, comparison function. Yeah, here we go. Greater than. Okay, so we're going to take 3 greater than operations here. We're going to drag in the values out of our sensors, and then we're also going to want to have a constant. So we need to generate a constant, and this is going to be our distance. So we're going to input that, and we can use the same constant for all 3 of these comparisons. There we go. There's almost certainly a better way of making this look pretty, but for now I'm kind of happy with it. And this constant will set to 1, just like we did before. So now it's no longer outputting a number, it's outputting a true or false. And so what we're going to need to do here is bring in a logic operation, and we can bring in an OR. Okay, so we bring in an OR operation. If we double click it, we can expand it so that we have 3 possible ORs. So if any of these become true, then we get a true signal. There we go. And then what we can do is we can drag that into our distance. So we are putting here a true or false value into distance. That means that this is going to go between 0 and 1. The float will become a Boolean. And what that means is we need to change this. So we are saying now if distance equals 1. Oh, it won't let me do that. Will it let me do equals equals? Yes, there we go. So if distance is equals to 1, or actually because it's true false, we can probably just write distance like that. And then if it becomes true, it will allow us to come over. It will probably cast. So let's test that and see how this works. So we're going to connect and run the Robotino program. Oh, probably should reset this. Let's see. There we go. We are reset. Okay. Let's just stop, connect, and start. There we go. So our Robotino is moving. Let's put this over here. There we go. We triggered. Don't know which one triggered. It's not actually really very easy to tell here. But there we go. So now we have a much better, much smoother obstacle avoidance program, because we're detecting out of 3 possible sensors on the front of the Robotino. So it's much more likely to see something before it hits it. So let's see how it does over here with this red object. Yep, there we go. Saw it. And it'll just keep going. Perfect. So I hope that was a good insight into how to do basic obstacle avoidance within the Robotino software. Thank you. Join me again next time. And that's it. I hope you found this video useful. Please feel free to like and subscribe for more content coming soon.